I'm Anil Kumar sharing with you some multiple choice questions which will help you review for exams. This series is good for high school students and the students who will be taking up calculus. Even first year university students can benefit from these questions. I'll have about 10 questions in this series, all on logarithmic functions, multiple choice as shown here. For every question, I'll also give an explanation which will help you review the concepts. The question here is, the expression log to the base b x to the power of n has the restrictions one of these: x greater than equal to 0, n greater than equal to 0, b greater than equal to 0, or none of the above. So you can always pause the video, answer the question, and then look into my suggestions. So if you are sketching the log graph, it may look like this, correct? Or it may look like this. Let me show. Right? So, or it may look like this. And what you'll observe that for the value of x to be 1, we get y value is 0. So it could be always increasing or always decreasing. That becomes the graph of the function. And as you know from here, this is log to the base b of x. So we have restrictions on this particular function, and the restrictions are, what are the restrictions? Let me write down those restrictions and then we'll select the right choice. Restrictions are that x has to be greater than 0, since this is an asymptote, you can see, right? Now, so that is one. And second, the base b is, as far as the base is concerned, it cannot be negative, since equivalent expression for this is exponential function, where we cannot have a negative base, correct? So base b is also greater than 0. And here we have a restriction also, that b is not equal to 1. If b is equal to 1, then you get 1 to the power of anything is 1. Do you understand? So for b equals to 1, it is a constant function. It is a constant function. Is that okay? Because 1 to the power of anything, let it be n, is always equal to 1. Do you get an idea, right? Of course, n could be any number here. Okay, so that is not an exponential function, and log is reciprocal of exponential function, so we don't treat that as an equivalent value, right? So this is not there in our restrictions given to us. As far as n is concerned, the exponent actually can belongs to all real numbers. There are no restrictions on the value of n, correct? So that is all real numbers. So if you see this, none of them is the correct option. So option D is just the right one, right? None of them is correct. So that is how we should be answering, and I hope it helps you to understand how could we, it helps you to understand domain and range of the function, correct? So that is how domain range is. Now can you tell me, when will the function have this graph always decreasing? Think about it. When will the function have the graph always decreasing? So give me an example for this. Okay, so give an example where the logarithmic function is always decreasing. Now let's move on to the next question. So the question here is, the expression log to the base of 1 over p of q, where p and q are greater than 0, p is not equal to 1, is always positive, can have any real number as its output value, right? Is greater than 1, or is not defined for q equals to 1, right? So this is very much like our previous question, but here we are basically talking about the range, right? So when we say this expression is equal to what, we are actually looking into the range. So as I had sketched earlier, the log function will be kind of like this, right? So for any value of p, right? It could be like this also, right? So it could be like this also. You need to figure out which one will be what, depending on the values of p, q, whatever, right? That you have to figure out. Okay, we'll keep it till the end. So what you see here is that this function, the output of this function, we should say y value, actually belongs to real numbers, right? So it can have any real number as the output, since the range has no restriction for a logarithmic function. Perfect. So I hope that helps you to understand the concept about domain and range with the first two questions. And now let's move forward and then see what are equivalent logarithmic functions. Now here is the next question. The expression log to the base 1 over p of 1, where p is greater than 1, is not defined, is equal to 1, is equal to 0, or is it equal to 1 over p? So you can always pause and answer the question. Here is how I'll do it, right? So it is very similar to the questions which we just did. Let me sketch the logarithmic graph once again, which will give you an idea, right? So that is what we have. Now in this graph, we are looking for the value x here and the y value. So what we're trying to figure out is log 1 over p of 1 is equal to what value of y? That is the real question. So I hope now it is absolutely clear what value of y, what is the value of y for this expressions on the left side. Now from the graph, it is very clear. At 1 it is 0, so we know it is equal to 0, option C, if you sketch a graph. So at this stage you learn that sketching graph of a logarithmic function helps you to understand it better, and you could answer all the questions which we have so far discussed just from the graph. It gives you domain and range and fairly good idea about the value of the function, right? Now we will get into solving equations algebraically, right? So when I write log to the base of something is y, I'm trying to say that that something 1 is equals to 1 over p to the power of y. Do you see that? So that is the exponential form. So this is called the exponential equivalent form. So as you know, logarithmic is inverse of exponential form. So these two are equivalent statements or equations. Now what do you know? What should be y? Now y should definitely be equal to 0, since you know anything, let's say n to the power of 0 is always 1. And that's the reason why all logarithmic graphs which are not transformed, the basic ones, will always have x-intercept at 1, 0. So we'll always have x-intercept at x value of 1, y value 0. That is why we are saying x-intercept. So I hope this part is very clear to you. So now you have fairly good idea about what logarithmic functions are and how they can be expressed as exponential functions. So let's now get to next level of questions, where we will see the exponential function and then answer, right? So the question here is, the expression 8 to the power of x equals to 2 is equivalent to which one of these? So now I'm saying 8 to the power of x is equal to 2. Now this is, as I said, an equation which involves exponents, right? So it's called exponential equation. Perfect. Now the idea is how to write this equation as logarithmic equation, right? So as a log function. That is what we will concentrate on. So here what you see is we are given this 8 is actually the base, and x is exponent. Correct? So base remains same whenever you write in logarithmic function. So what we get here is, if I take log on both the sides with this base 8, right? So log to the base 8, then we get 8 to the power of x is equal to log to the base 8 of 2, right? And logarithmic law says We can use the power rule to write this as, let me write equivalent expression here. X times log to the base 8 of 8 is equals to log to the base of 8 of 2, and this portion is 1, and therefore we can write this as x is equals to log to the base 8 of 2, correct? So I did all this, but it was not really required. As you move forward, you can immediately write exponential form into the logarithmic form. That is by definition, right? So this x will be equal to log to the base 8 of that number, correct? So that is how we will be writing logarithmic expressions from the exponential expressions, correct? So in general, if we have log to the base b of some value, let's say p equals to x, then in exponential form it will be written as whatever the base is, base to the power of x is equal to p, correct? And vice versa, correct? So these are equivalent forms. So I hope that point is absolutely clear. So let's move forward and do a few more questions. Two more questions to go. The expression here is log to the base 1 over p of x, where x is greater than 0, is always decreasing for 4 choices are given to you. I'd like you to go through these choices, and let me sketch once again the logarithmic function, what we want. Always decreasing really means something like this, correct? That is always decreasing. Now, as you know, this point here will be at x equals to 1. Right, this point here will be x equals to 1. Now, let us see what really works for us. So we are given the expression log 1 over p of x, and we want this to be always decreasing. Let me write this in exponential form. So it will look like this. X is equals to something over, 1 over p, the base remains same, over y. Now, when do I get always decreasing? As you know, in exponential functions, always decreasing is when you have this value between 0 and 1. Do you see that? So 1 over p should be actually less than 1, correct? 1 over p should be actually less than 1 and greater than 0. Only then you will see that the graph is always decreasing. So if I multiply by p, what I get? I get 0, 1, and then I get here p. So that clearly indicates that for this given value, 1 is always greater than 0, perfect. So p has to be greater than 1. We can multiply by p since we know that p is non-negative, right? So in any log, we know in this case, since p is always positive, right? P is always greater than 0. So you can always multiply and get this. So we get a result as p greater than 1. Now, we really don't have this option here, but this option B works for us. Since p is between 1 and 2, will also result into always decreasing function. You get an idea, right? So truly speaking, we get this kind of a graph when p is greater than 1, correct? So if we have something like this to the power of whatever, we'll have always decreasing graph, as you learned in exponential functions. So let me sketch an exponential function for this. The exponential function will be always decreasing, kind of like this. Do you see that? That is what we have, b to the power of x if b is between 0 and 1. So that is between 0 and 1. Is it okay? Now, since we wrote 1 over p, so we are saying greater than 1. You get an idea, correct? So that is how it should be answered. Let's move on to the next question. The last question here is, the value log to the base 2 of 100 is between what? Now that is a very important question from test point of view. I'd like you to pause the video, try to understand, and then look into my suggestions. So we want to find log to the base 2 of 100 is basically equal to what? So let it be equal to y, right? So it really means that 100 is equals to 2 to the power of y. So we are trying to figure out what is the value of y. Y is between which values? This is what we're trying to find. So let's go for powers of 2. So what is 2 to the power of 4? 2 to the power of 4 is 16, right? 2 to the power of 5 is 32. 2 to the power of 6 is 64. And 2 to the power of 7 is twice this, which is 128. Correct? So we want a value which is 100. So 100 is between these two values. Perfect. That is where the exponent is between 6 and 7, or the y value is actually greater than 6 but less than 7. So option C is the right option. Perfect. So with this, I think you get fairly good idea about logarithmic functions, their domain range, and how to write them as exponential functions, and how to write exponential functions as logarithmic functions. In part 2, we'll look into laws of logarithms, solve few equations, and in part 3, we'll have multiple choice questions based on applications. So I hope with that you'll have a good review of logarithmic functions. Feel free to make suggestions, post questions, and if you like and subscribe, that'll be great. Thanks and all the best.